The following content is created by DrAvitech. Your support and donation will help me continue to offer high-quality educational resources for free. To make a donation, send an email to 6drcyril@gmail.com or comment donations below. Welcome guys, I'm DrAvitech, and in this video we're going to be solving this very equation on Fourier series. So we have to find a Fourier series of the function defined by f of x equal 1 plus x plus s squared. That function is definitely not even, it's definitely not odd. So we have to find it within that range. So let's get started. It means we have to find all of the three coefficients, a naught, a sub n, and b sub n. So let's get started. It's going to be a tedious one, a very tedious one. So let's see. So f of x, the first one is a naught. So a naught is 1 over pi, integral from minus pi to pi of f of x dx. So this will be 1 over pi, integral from minus pi to pi. Now f of x is 1 plus x plus s squared dx. I think I might want to, it's your choice. You can start to even rearrange this whole expression. You can start to just rearrange it. So this will be, let me stand here, even though darkness will not be at this part. So this will become 1 over pi. Now let's integrate this whole expression. If you integrate 1, you basically get x. You integrate x, you will get s squared over 2. Integrate s squared, you have s cubed over 3. Because the rule of integration says you're always going to be saying 1 plus 1 over, so this x here has 1. So when you say 1 plus 1 over 1 plus 1, that means this will be s2 over 2. Just like that for this one. This is 2. So you say 2 plus 1 over 2 plus 1. So I believe before doing Fourier series, every single student is already aware of the general rules of integration. So you put your minus pi to pi. Now at this point, anywhere you see x, you basically put in your limits. So anywhere you see x, you put in your limits. This will be a bulk equation. So this is 1 over pi. Now anywhere you see s, let us put pi. So this will be pi plus pi squared over 2 plus pi cubed over 3. So this is the first part. Then minus. The second part, anywhere you see s, you put minus pi. So this will be minus pi plus, to save us stress, if you should square, because we are the square part, minus pi squared is still pi squared. So this will be pi squared over 2. If you put your minus pi here, minus pi raised to the power of 3 is still minus pi raised to the power of 3 all over 3. So I just have to do that part very fast. But it's still the same, please. You can just give it a pause, check it out with your calculator. So let me open up this bracket. So this will be 1 over pi. Then let's take out the brackets. This will be plus, pi plus pi squared over 2 plus pi cubed over 3. Minus times minus will give me plus. So this is plus pi. Minus times plus will give me minus. This will be minus pi squared over 2. The minus times minus will give me plus pi cubed over 3. So this is what I have. Now if you take note of this, if you take a look at this, pi squared over 2 minus pi squared over 2 is gone. It's going to be 0. So this is gone, this is gone. All right, now this is pi plus pi. That's double of itself. That's double of itself. This is pi cubed over 3. This is also pi cubed over 3. So that's double of itself. So what I'll be having will become 1 over pi into pi plus pi is 2 pi. Then pi cubed over 3 plus another one will give me 2 pi cubed all over what? 3. All right. Now if you look at this expression carefully, something is common. 2 pi is common because I have 2 pi here. I also have 2 pi here. So 2 pi is common. So this will be 1 over pi times, let's bring out the 2 pi. Then open this up. 2 pi over 2 pi is 1. Plus 2 pi cubed divided by 2 pi will just give me pi squared. Then divided by 3. It's actually the same thing. It's actually the same thing. This 2 pi here times 1 will give us 2 pi. 2 pi times pi squared is 2 pi cubed. So it's still the same thing. Now pi can cancel out pi, can take care of itself, so it's gone. So what will be left here will become 2 into 1 plus pi squared over 3. So you want to keep that. That's the answer for A naught. You want to keep that guy. Next is A sub n. This is going to be tedious. So A sub n is 1 over pi integral from minus pi to pi of f of x cos nx dx. So that's what we're going to be having. Now, let's put in f of x. So this is 1 over pi integral from minus pi to pi. F of x is 1 plus x plus s squared cos nx dx. Okay, now this is where integration by parts comes in. So this will become 1 over pi. Now write this expression you see here. 1 plus x plus s squared. Write it out. So this is it. Next, what you'll be doing to this guy is to differentiate it until you get 0. So this expression, you're differentiating the first time. You will get 1 plus 2x. How did I know it's 1 plus 2x? When you differentiate 1, you will get a constant. When you differentiate x, you will get 1. Then when you differentiate s squared, you will get 2x. And this expression here, when you differentiate this expression again, you will get 2. Then you want to keep that. Because after you differentiate these 2, you will then get 0. So you don't want to do that. So that's where you're going to end. Should I put a bracket? It doesn't change anything. And this is cosine of nx. Cosine of nx. You will be integrating this one. So when you integrate cos, you would have sine. So this is sine nx over. When you differentiate this nx, you would have n. So you need to divide by that very thing. Alright, so that's what we have. Now this expression here, we're going to integrate it again for these last two guys. So if you want to integrate this expression, you will start by, let me put the red bracket. So when you integrate sine, you will get minus cos nx, then divided by, when you differentiate this nx, you would have n. That n will come and make this very n. So now make it n squared. So that's for this one. This expression here integrates it again for this one. So first of all, let me put in my minus. Let me put in my minus. So I have minus. When you integrate cosine, you have sine. Then this nx will stay like that, nx. But when you differentiate nx, you will have n. So that n will come and make this n squared. So then make it n cubed. So then make it n cubed. And then the correct sign for this is plus, minus, plus. Then you put in your limit, minus pi to pi. Woo! That's massive. So let's proceed. So let's simplify this whole stuff. But I really think I shouldn't simplify. Do you know why? This is sine here. I know that when I put in pi, anywhere I see sine, it will give me 0. So I think I can really save myself some stress, some time, because sine of n pi is 0. Sine of minus n pi is still 0. So no need for me to stress myself. This part will give me 0 because this sine of nx, anytime I put the limit here, to give me 0. So this is 0. I don't want to stress myself. This is 0. This sign here will also give me 0. So the only useful one is this one in the middle. So this one in the middle, minus times minus will give me plus. So this is 1 over pi. Then I have 1 plus 2x cos nx over n squared from minus pi to pi. All right. Now if I look at this expression carefully, the n squared is a constant. So let me just bring it out. So this will become 1 over n squared pi. Then I have 1 plus 2x cosine of nx. From minus pi to pi. Now, anywhere I see x, I'm going to be putting pi. So let's get started. This will be 1 over n squared pi. Then this is 1 plus 2 pi cosine of n pi. So this is the first part. Minus. For the second part, anywhere I see x, I'm going to put minus pi. So this is 1. If you should put minus pi here, 2 times minus pi is minus 2 pi. And then cosine, if you put minus pi here, you would have n times minus pi is minus n pi. But you know that from everything we've been doing, the negative and the positive are the same. So you shouldn't, it's not a problem. Let me say that again. Cosine of n pi is the same thing as cosine of minus n pi, because cos is an even function. So this minus is still the same as when it's positive. So let's not really stress ourselves about that. Now this is 1 over n squared pi. Then this is 1 plus 2 pi cosine of n pi. Now, there are different ways to do this. So, what I want to do, see what I'll do. Since there's cos n pi here, there's also cos n pi. This means that cos n pi is common on both sides. So why not just bring out the cos n pi? So this will be cosine of n pi. Then I'll be wiping it off here. So if I'm writing the cosine of n pi outside, meaning I won't write it anymore. Instead, I'll write 1 plus 2 pi and minus 1 minus 2 pi, because I'll factorize the cos n pi out. Now, cosine of n pi has a special value. That special value is minus 1 to the power of n. And this is n squared pi. And then, let's simplify this. So open up this bracket. This is 1 plus 2 pi. Minus times 1 is minus 1. Okay, the minus times minus is plus 2 pi. Now 1 minus 1 is 0. So that's gone. So what will be left is 2 pi plus 2 pi. So this is minus 1 to the power of n over n squared pi times 2 pi plus 2 pi is 4 pi. So when pi cancels out pi, what will be left is 4 into minus 1 to the power of n over n squared. So that's my A sub n. That's a lot. That's a lot. Okay. So I have to wipe this part. Let me just keep the answer here for every single thing. So A naught is 2 into 1 plus pi squared over 3. And then A sub n is 4 into minus 1 to the power of n over n squared. So now let's find B sub n. B sub n is 1 over pi integral from minus pi to pi of f of x sine nx dx. So that's what we have. Now what I'm going to do is to say this is 1 over pi, then I have integral from minus pi to pi. The function is 1 plus x squared sine nx dx. Now what I'm going to be doing next is to use integration by parts, but there's a shorter way for me to do that. So this is 1 over pi. Now this expression, I'm going to write it. So I'm going to write this one. So this is 1 plus x squared. And I'm going to start differentiating this until I get 0. So I'm going to differentiate this. And when I do so, this one, when you differentiate 1, you will get 0. When you differentiate x, you will get 1. So this is 1. When you differentiate s squared, you will get 2x. That's what I'm going to get. And then, you're going to differentiate this again. So when you differentiate this one, you get 0. When you differentiate 2s, you get 2. All right. Let me kind of put a bracket. Now, this sine nx, you are going to be integrating this one. You're going to be integrating this. So let me open up a bracket everywhere for it. So when you integrate sine, you get minus cos nx. Then you have to divide by the derivative of nx. When you differentiate nx, you will get n. So you have to divide by that very n. Then let's close this up. Now this bracket you see here, this red bracket, we're going to integrate it again. So to start with, this is minus. We're going to write the minus. When you integrate cos, you would have sine nx over. When you differentiate ns, you will get n. That n will come and meet this n at the bottom. to give us n squared. To give us n squared. So this is what you have for this part. Good. Now this red bracket, we're going to integrate it again for this part. So let us write our minus first. The sine, when you integrate sine, you get minus cos. So this is times minus cos nx. Now this ns, when you differentiate the ns, you will get n. That n will come and make this n squared to form an n cubed. And then the correct sign for this will be plus, minus, plus. And our interval is minus pi to pi. That's our interval. All right, now at this point, let's see. I really want to save myself some time. Now previously, remember I said that sine would always give us 0 because of the interval that we are in. So I'm taking this out. I'm going to get 0. So let me just take this part out. So I'm going to simplify the remaining part. So this is 1 over pi. And I'm going to be having, this minus can come outside to this place. So this minus can come here. So this is minus into 1 plus x plus s squared cosine of nx, everything over n. And then plus 2. Minus times minus is positive. So this will be cos nx over n cubed from minus pi to pi. All right. So that's what we have. It's beautiful, right? So what I'm going to do next is to say that anywhere I see x, I'm basically going to be putting pi. Anywhere I see x, I'm going to be putting in pi. So let's get started with that. So this will be 1 over pi. Then I'm going to be having minus into 1 plus pi squared cosine of n pi all over n plus 2 cos n pi all over n cubed. So this is the first part. Let me put that here. This is the first part, where all of the n, I am putting just pi. Now the second part of this is to say minus, then anywhere I see x this time around, I'm going to be putting minus pi. Anywhere I see x, I'm going to be putting minus pi. So this is minus, open up a bracket, 1, put in minus pi here. So this is minus pi plus pi squared. Because if this is s squared and you put minus pi squared will give us a positive answer. That's why this pi squared is here. And then cosine, remember that even if you put a negative, it's still the same as putting the positive for cosine. So this is cos n pi over n. I should be writing this thing in black. Anyway, it's fine. Then plus 2 cos. Next, this is minus pi, but the minus is still the same as the plus. So this will be cos of n pi all over n cubed. Okay. From this point, I'm going to be using black. I don't like red. Red signifies danger. Okay. But that it's not really necessary. So let's see what all of this is going to be. So this will be 1 over pi. Now there's a better way to simplify problems. I already know that this will cancel out, but there's a better way to simplify problems. So I'm going to leave it this way since it's more convenient for you. I'm going to leave it like this. So this minus will stay. So this is minus 1 plus pi squared cosine of n pi over n. Then plus 2 cos n pi over n cubed. Now let's open this up. Minus times minus is plus. 1 minus pi plus pi squared cosine of n pi divided by n. Then minus times this plus is minus 2 cos n pi all over n cubed. Now look at it this way. 2, this is positive 2 cos n pi over n cubed. This is the negative part of it. So they'll both give me 0. They'll both take care of themselves. So these two guys are gone. Now these two are the ones remaining. But if these two are the ones remaining, what are the constant terms here? The constant term is the cos n pi over n. Because I have cos n pi over n, I also have cos n pi over n here. So let me bring it out. So this will be cos n pi over n. Now don't forget that there's a pi, so put your pi. Now what will be remaining? What will be remaining is minus open bracket 1 plus pi squared, then plus 1 minus pi plus pi squared. That's what's going to be remaining. Now cos n pi has a special value. That special value is minus 1 to the power of n, all over n pi. Now let's open up the bracket. Minus times 1 is minus 1. Minus times pi is minus pi. Minus times pi squared is minus pi squared. Plus times 1, in fact, when you open everything by plus, it's still going to be the same. So this is plus 1 minus pi plus pi squared. Now what's going to happen here? Something beautiful. Some guys will be cancelling out. Minus 1 plus 1 is gone. Minus pi squared plus pi squared is also gone. So minus 1 plus 1 is gone. Minus pi squared plus pi squared is also gone. So what's remaining is minus pi minus pi. So this is minus 1 to the power of n over n pi times minus pi is minus 2 pi. So the pi here, we cancel out this pi. So this means I'll be having minus 2 into minus 1 to the power of n over n. So that's my b sub n. Man, minus 2 into minus 1 to the power of n over n. So this is what we have for b sub n. Now let us find the Fourier series coefficient and be done with this. So let's find the Fourier series coefficient. F of x is equal a naught over 2 plus the sum from n equal to 1 to infinity of a sub n cos nx plus the sum from n equal to 1 to infinity of b sub n sine nx. So f of x is equal, I think this marker is dead. Now a naught, this is the value of a naught. So a naught is 2 plus, 2 bracket 1 plus pi squared over 3. Now don't forget that there's an over 2 with the formula, so put that over 2 here. And then plus the sum from n equal to 1 to infinity, a sub n is that. So we have 4 into minus 1 to the power of n over n squared cos nx plus the sum from n equal to 1 to infinity. Now for b sub n, this is what we have. Minus 2 into minus 1 to the power of n over n sine nx. Man! Alright. So 2 will take care of 2. So f of x is equal 1 plus pi squared over 3. Okay. Now, what is the constant term here? This 4 is a constant because the summation is in terms of n. So the 4 is a constant. So this is plus 4 with the sum from n equal to 1 to infinity. What will be remaining is minus 1 to the power of n over n squared cos nx. And then here, the constant is minus 2. So this is minus 2 with the sum from n equal to 1 to infinity of minus 1 to the power of n over n sine nx. So if the equation says in terms of n, leave your answer. This will be our answer in terms of n. This will be our answer in terms of n. All right. So that's our answer in terms of what? In terms of n. Now let's proceed. Let us bring out some terms in the Fourier series. Let us, I think, to the third harmonic. So let's bring out some terms in the Fourier series. So f of x is equal 1 plus pi squared over 3 and then plus 4. Let's bring out some terms. So let n equal to 1. Minus 1 to the power of 1 is minus 1. So this will be minus cos x. Look at it this way. If you're putting n equal to 1, this is minus 1 to the power of 1. So that's minus 1 over 1 squared is still 1. Cos 1x is still cos x. So this is just negative cos x. You can simplify that in your notes. Then next, when n is equal to 2, minus 1 squared is plus. So this will be 1 over 2 squared cosine of 2x. The next will be 3. So that's minus 1 over 3 squared cosine of 3x. And that's the third harmonic. Remember that you really do not need to go on to infinity because you can't get to infinity. In fact, Fourier series is an infinite representation. But if you add up some harmonics, you'll be able to start seeing that what you are getting is looking like our function. So let's proceed. I'm just going to end here, and I'm going to end here. Now the next part, minus 2. Now if n is equal to 1, same thing is going to happen because it's behaving in the same way. So this will be minus sine x plus 1 over 2 sine 2x plus, what is this guy? Minus 1 over 3 sine 3x. Let me explain that last part. I said minus 1 over 3 because when n is equal to 3, minus 1 to the power of 3 is minus 1. Over your n is 3, so over 3 sine 3x. And you can't really get to infinity, so you end it there. So this right here will be the Fourier series of the function. So this is what we have as the Fourier series. Now the second part that says we should deduce that very function. I feel like there's a problem with that. Basically, when I set s as pi over 2, I was having some issues. So unless of course I'm missing something, then you can let me know, because I tried it. I even had to edit this video to remove that part because I was having a value that was not pi over 4. The series for pi over 4 is 1 take away a third plus 1/5, take away 1/7, and just like that. So that's it. But I was not getting it, and the only way to get this is from this function. It's from this function, because you see this part here, this is 1 over 4. So it means I need to set all of this to be 0. I need to set all these values to be 0. And the only way for this to be 0 is not by putting pi over 2. Because if I should put pi over 2, when I get to this very place, if I put my pi over 2 here, I'll be getting minus 1. So this will not be eliminated. Now when you come here and you set your pi as pi over 2, good. By setting x as pi over 2 here, good. All of the even guys will go away. All of the even guys will go away. Fine and beautiful. The even guys will disappear. That's not an issue. But this cosine cannot be removed. Another thing is, you see this portion, this very pi squared over 3, we'll be having an issue with this other x squared when you put your pi over 2 here. They won't cancel out. They're not going to cancel out. So unless of course, there's no unless of course. So unless I'm missing something, I think this is the end of the video. If I'm asked a question and I'm asked to deduce this, I'll just put what the answer is. Because I kind of feel like I even had to go graph this function. So I graphed this, then I graphed this, and they were all the same. So this is a perfect representation. In fact, I even used it in terms of the summation. So I graphed using this, and it was equivalent to this. It was just the same with this. So I see no reason why the Fourier series is not wrong. I removed the cosine part in my graphing calculator, removed it, yet it was not giving me the function. I removed the sine, it's not giving me the function, but everything together gave me the function. So I don't just know. Sometimes it is not all things that can be deduced. And when you say set s equal to 2, you really have to be certain that it's giving you that. So unless I'm missing something, which I can be wrong, but this is just my discovery. And with this, I'm going to end the video. Thank you very much for watching. See you in the next one.